Exercise 4. So in exercise 3, you create a code that looks something like this. You've defined positions and velocities of the Earth and asteroid, and there is a loop set up where the position of the Earth and the position of the asteroid are continually updated, in a sense like frames of a video with a very short time dt. And the asteroid moves and the Earth moves. If you run it, it'll look something like this. Ideally, closest approach would be 0, but 132 meters is basically the asteroid has hit the Earth, which is what you expect because the problem was set up this way. It's not precisely 0 because we have a line here that sets up the time between frames, the time step within the loop. And 0.1 seconds is pretty small, but the asteroid and the Earth are moving fast enough that that makes a difference of about 100 meters. To get better accuracy, you would make this dt smaller. So now in exercise 4, you're going to add something. You're going to add a force exerted on the asteroid. Now, this can be done in one line or two. Set up the magnitude of the force and then set up the vector, or just do it all in one go. This would be a force acting on the asteroid, say by strapping a rocket engine to it. And then to see how that affects the motion of the asteroid, you need a mass of the asteroid. So we can use Newton's second law. And in this case, you're assuming the force is constant. So it can be calculated. It can be set up before the loop. Then within the loop, you need to incorporate a line that will show how the velocity of the asteroid is changing because of the force acting on it. And in the simplest approach, there could be one of two places you could do that. You could do it here on line 41 before you calculate the new position of the asteroid. And then use that new velocity to calculate the position change of the asteroid. Because if you recalculate the velocity of the asteroid here on line 41, then it's that new velocity that will calculate on line 42. Or you could say, I want to use the old velocity, the velocity at the beginning of the frame. In that case, you're saying I'm going to use the velocity at the beginning of this time step to calculate the new position of the asteroid, and then calculate the new velocity of the asteroid. So the question is, do you want to do things in the order of calculate velocity, then position, or calculate position and then velocity? There are other things you could think of, such as doing an average of the two, but these are the two primary choices, and there is one that works better. And that will be what we're showing you on this video. So here is a bit of code that is a simplified version of all this. In a loop, in this case, time is passing, and it shows calculating the new velocity using Newton's second law, and the idea that acceleration is change of velocity. So force over mass is acceleration, and that gives a change of velocity. So the new velocity is calculated, and then that new velocity is used to calculate the new position. Mathematically, that is the way that works best for these two simple choices. The reason is, if you do it in the opposite order, then the computer can't keep infinite digits. It has to round off numbers and throw away some of the digits. And that produces round-off error. And if you do things in the opposite order, the round-off error keeps getting bigger and bigger and bigger. So let's show you that happening. So here's another program in another situation, a satellite orbiting the Earth. And here's a loop over a certain amount of time, a certain number of orbits of the satellite. The force acting on the satellite is calculated. And then in this example, the new position is calculated using the old velocity in each step of the loop, and then the new velocity is calculated. So this is the opposite of what I just told you is the best way. And again, the problem with this is that mathematically the round-off errors keep getting bigger and bigger and bigger. Let me show you what that means. So this is the beginning of the simulation. The red dot is a satellite. And the satellite, things are set up so it should just go in a circle around the Earth. That's something that you can calculate. But if you do things calculating position first and then velocity, you can see that the orbit keeps getting bigger and bigger. Now that is not realistic. Realistically, you can calculate the speed and to produce an orbit of a particular radius or the other way around, and it should just be a circle. This is showing the effect of the round-off errors getting bigger and bigger and bigger. And that is what can happen as motion repeats if you do things in that order. So if you do position first and then velocity, round-off errors get out of control. If I comment out line 30 and uncomment line 32, then I'm doing things in the order that I'm telling you will work better. I'm calculating the new velocity and then the new position. And in this case, mathematically, the round-off errors will actually dampen out. They'll decrease. So let's show that happening. If the round-off error is not getting out of control, I should just see a circular orbit as you would expect. Okay, so in fact, mathematically, if you're going to choose either calculating position and then velocity or velocity and then position, the errors will not compound, will not increase if you do velocity first and then position, as is shown in the code snippet on the left. So, in what you're working on, you want to calculate the new velocity before calculating the new position. So you see what I've typed in a comment for line 41. You need to replace that with the calculation of the new velocity of the asteroid given the force acting on the asteroid and the mass. The effect of doing it the opposite way is most evident when you have some sort of repetitive motion, such as a spring or an orbit. But since we are doing something simple here, it's best just to always do it this way: velocity first and then position. If you go further into doing simulations, you may learn more complicated ways. But here we're just using ways that most directly map onto the equations that you're using to solve problems. Velocity change comes from acceleration, position change comes from velocity. And that should be the change you need to do for exercise 4. And with good choices of numbers, you should be able to get the asteroid to not hit the Earth.